All right, we're going to start here. We're going to take a minute just to let people join. All right, there we go. In 3, let me silence my phone. 2. Hello, everyone. Going to allow for some people to join, so we'll get started here in just a few moments. So once again, we're just going to allow some people to join. Thank you guys for joining us today. This should be a whole lot of fun. So again, we're just allowing some more people to join us, and we'll get started here in just a few moments. So just as a quick introduction, if you guys would like, you can take a look at the Zoom features that are down at the bottom of your screen. You'll see a chat box. If you guys want to let me know if you can hear me, everything is okay, just go ahead and say hello, say where you're from. Hi, Kathleen. Say where you guys are from. Let me know if you can hear me. And this will be the same place where we'll be able to take some questions from you in a little bit as well. So you can go ahead and again, just explore some of those features. Let us know where you're tuning in from. So hi from Lincoln Park Middle School, Clinton Township, some 5th graders in Birmingham. Welcome, guys. My virtual academy, welcome. So again, we'll be getting started here in just a moment. I do want to thank you guys for joining us this afternoon, almost at the holiday break. I have to imagine you're all pretty excited. We're all pretty excited here too. Over from Dearborn, another 5th grade classroom. I think I saw a bunch of you guys sign up and tune in. That's going to be cool. So I think we could go ahead and get started, and just sort of with a general introduction. I wanted to introduce myself. My name is Charles Gibson. I'm the Director of Innovation and Outreach here at the Michigan Science Center. And if you're not familiar with the Michigan Science Center, just want to tell you a little bit about all the great things that we have to offer. We're right down here in Midtown Detroit, right behind the Detroit Institute of Arts, next to the Charles H. Wright African American History Museum, the Detroit Historical Museum, right in that cultural center of Detroit. And you can come down, you can check out all the great things that we have to offer. Our IMAX theater, where we're showing a couple giant screen films. We have our brand new Toyota Engineering 4D theater, where we're showing extreme weather. That's a theater where you can actually get blasted in the face with water and sparks fly through the air and your seats rumble. That's a pretty immersive, pretty fun experience. We've got a planetarium, our electricity theater, our science stage, and then we have countless hands-on exhibits, some great things for you guys to experience. So if you've never been before, we'd love to have you come down. If you have been before, I can almost guarantee there's some new interactive experiences that you guys can have with us. You can check out some of the different live presentations that we offer. You can join in on some of the hands-on classroom sessions that we lead on weekends. Those are always changing as well. And so we'd love to have you come down and check us out. Just a quick note, we are actually celebrating our 5th birthday. MySci is turning 5. And that's going to be on December 26th. That's the day after Christmas. We opened 5 years ago on that day. And we're celebrating with free general admission. So we'd love to have you come down, check out all the great things that we have to offer. There's also going to be birthday cake. So birthday cake will be available if you guys want to come down and grab a slice and just join in on the fun, all the interactive experiences that we have. Hey, I did want to launch a quick poll real quick. So I know that you guys responded in some of your the chat right there, but I'm going to launch a quick poll, and you can go ahead and just let me know, have you visited the Michigan Science Center in Detroit? So let us know if I guess a group of you or any of you have visited. If you've never visited the Science Center before, no one's visited in your classroom, we just want to get an idea of who's come and had some fun with us learning and checking out all of our different hands-on exhibits. While this poll is in progress, I'll let you guys go ahead and still complete that. Wanted to let you know that we also have winter camps coming up. So January 2nd, we're actually closed on the New Year's Day. January 2nd through the 5th, we'll be having our winter camps, and we do have some spaces available left for that. You can come down, you can spend the whole day with us and learn about all different things STEM. That's science, technology, engineering, and math. So I've got 9 responses of 12, so I'll give you guys just another few seconds to get your responses in, but it looks like a good 3/4 of you guys have been to the Michigan Science Center before. So that's great. Awesome. So we'll go ahead and we'll end that poll. So thank you guys for that. So this introductory webinar is all about 1001 Inventions, and we're able to do this through our new distance learning program called ECHO. ECHO stands for Engaging, Collaborative, Hands-on Learning. And we can connect to you in your classroom. And if you've participated in this webinar or a webinar in the past with us, you're eligible for 10% off of a future distance learning program. And you can check out our website and learn a little bit more about some of those programs. But again, we're here for 1001 Inventions, and I want to tell you just a little bit about that. 1001 Inventions here at the Michigan Science Center opened October 7th, and it's going to be closing on January 7th. So we're in our final weeks here with this incredible exhibit. This exhibit showcases the diverse spectrum of bold thinkers and new technologies that were produced by this multi-faith, multicultural civilization reaching from Spain all the way to China during this period of the European Renaissance that was often referred to as the Dark Ages in Europe. We've got more than 60 interactive hands-on exhibits. We've got a short film, some live science presentations and demonstrations that we can do with you. And we're introducing you to the golden age of Muslim civilization, a time where men and women of different languages, faiths, cultures all worked together in harmony, building upon knowledge of ancient civilizations and achieving breakthroughs that still influence our world today. That's that key part. All of these innovations that took place thousands of years ago still have an impact on how we operate and live as a society today. 1001 Inventions is designed to inspire curiosity, creativity, innovation among the next generation. That's all of you. And we're supporting this STEM, science, technology, engineering, and math economy. The exhibit provides an exciting learning opportunity while promoting intercultural understanding and fostering mutual understanding and social inclusion. So in this next 15 minutes or so, I'd like to introduce you to some of the scientists that you can meet while you're in this exhibition. And again, we're only here for another 2 weeks, and then our scientists are leaving and heading off to the next place. So I'd first like to introduce you to a scientist who's going to let you know a little bit about this structure that's right behind me. So I'll let our special guest introduce herself.
Hi everybody, my name is Suteta Al-Mahamali. I'm an expert in math, Arabic literature, law. I'm a bit of a smart cookie. But I'm going to be explaining to you how the elephant clock works. Now the elephant clock was created by Al-Jazari. It was created to represent unity between different cultures. And that's what makes this clock so significant. Because gear clocks, water clocks, astrolabes, all of those things were used to tell time, but they had already been invented. This clock, what makes this clock so special is what it represents. So we've got all of these different components, all of these different cultures working together. We've got an Indian elephant, we've got Grecian hydraulic technology, Arabic people riding the elephant, Chinese dragons, an Egyptian phoenix. All of these different things are working together to make the clock work, which is sort of a fitting metaphor for how we want the world to work, right? We want different people to come together and work together to make the world work, right? So how this clock works is actually quite interesting. I said before that it was using Grecian hydraulic technology. Now that's just a fancy way of saying it's powered by water. Inside of this elephant, there is a tank of water, and inside of that tank of water, there's a bowl with a very small hole in it. So that bowl is going to slowly sink. Now, as that bowl is sinking, it's actually pulling a string that runs up to that man in green over there, the scribe. So as the bowl is sinking, the man is being pulled and slowly turning, and he's going to be pointing to the minutes of the hour with his pen. So when the bowl has fully sunk, that means that the 30 minutes is up, and it pulls another string that runs through that pillar to the top chamber all the way up there. So what's going to happen, it's going to pull down a tube, and that's going to create a track for a ball to fall out of the top chamber, drop out of the eagle's mouth, and then it's going to fall into the dragon's mouth, all right? So it's going to fall into the dragon's mouth, and the dragon is going to tip over and empty the ball into the metal vase. That's now how we know that the half hour is up. Now I have a similar, a demonstration that I can actually show you how that works right here. So it's the same concept with the elephant clock. I said before that it's powered by a bowl sinking in a tank of water. I have my tank of water, I have my bowl with my very small hole in it. So that bowl is actually going to sink. As that bowl is sinking, it is pulling this string that runs up to this spool of thread. So as the bowl is sinking, this thread is going to be turning, similar to the same way that as the bowl was sinking, it was pulling the man in green, the scribe. Now, when the bowl fully sinks, it's actually going to sort of do this big chain reaction, similar to how it works in the clock. The bowl's going to fully sink. The spool is going to go spinning. It's going to go crazy, right? That's how we know that the bowl will fully sink. So this is sort of the a representation of how that works, a good visualization. And it looks like it's about to happen right now. Here it comes. The bowl has fully sunk, and the spool spins, letting us know that the hour is up. It's the same concept with the elephant clock. So, as we can see, this elephant clock is a beautiful representation of how things work. It's a representation of how we want things to work. And it uses some pretty cool physics just to get the whole thing working. Sort of a Rube Goldberg version 1.
Awesome. So, hey, we were thinking we can take some questions too. So, as any question might come to you, go ahead and type those up in your chat box, and we'll see if we can answer some of those questions for you about the clock that we have here, about the exhibition, about the Science Center, anything like that, and we'll be happy to respond to some of those. For those of you that are watching on Facebook, you can go ahead and just leave a comment. Leave a comment in the Facebook, and we'll monitor those, and we'll see if we can get some additional questions going and some additional engagement. We want this to really be an interactive experience for you. We want you to really understand that we're here kind of listening and actively taking some of those questions. So we have one from Wendy.
Well, first we've got one from Lindsay, so I'm going to answer that one first. The reason why there's a hole in the bottom of the bowl, so the bowl is going to, without the hole in the bowl, it's not going to sink. It's just gonna sit there, especially if you have a wooden bowl, which some versions do use wooden bowls. My version has a wooden bowl. It's just got little weights in it, so it's gonna sink a little faster. But without the hole in the bowl, it's not gonna sink. So the size of the hole is actually gonna it's going to restrict how long it's going to take to sink. So if we have too small of a hole, it's not going to sink fast enough. If we have too big of a hole, it's going to sink too fast, right? How did they get the idea to make it look like an elephant? Well, again, it's representing different cultures. So the elephant is supposed to represent Indian culture. So that's so the whole thing is supposed to represent people working together. Otherwise, you know, they could just use, again, a picture like I use right here. But they used an Indian. Al-Jazari decided to use an Indian elephant because that was a way to represent people working together. And does it use any type of electricity? No, it just uses physics. Al-Jazari was a mechanical engineer. He was the man. This was an amazing invention that he made. He also created an invention that converted circular motion into linear motion, which later was used to make water pumps and engines. So he didn't actually need to use electricity, but he found ways to sort of warp physics to make things work the way he wants to. Sort of miracles of physics, and it's complicated. Using physics to actually power things rather than necessarily using electricity. Why did they choose to power it by water? Well, water clocks had already been something that was invented. He also was very interested in water. He was using he used things like water raising machines. He also, when he made his invention that converted circular motion into linear motion, converting the two and combining them, which is the same thing that's used for water pumps, that was something that was incredibly useful for water. So he liked to use actually water as a source of power. And again, the using water as a power, that's using a technology that was created by Greek people. So that was representing Grecian culture. Do you have to use string, or could you use another type of material like yarn? Yes, any type of string would work. Originally, when I made this part right here, I was using just regular thread, but I found that got tangled really easily, and it would just get, it would break off really easily, so I like to use a stronger thread right here. Yarn would actually be very good. The only problem that I would say would be with yarn is that it can sometimes absorb water.
So we had one more question from Facebook. We wanted to hear who you were again and what your contributions were.
Well, my name is Suteta. Thank you for asking, by the way. My name is Suteta Al-Mahamali. I am a mathematician. What I'm famous for is working with algebra, and especially working with algebra and using that with law. So in my time, there were people who were buying houses. You would have people who had say you had one person who was buying a mansion and one person who was buying a very small house. You don't want those people to be paying the same price, right? So when I was working with law, I actually figured out ways to find equations to work out how much that house was worth. So things would be a little more equal for people. So you wouldn't have someone who's buying like a shack paying the same amount as someone who's buying like a castle. Does that make sense?
Well, thank you very much for joining us today.
Am I famous? Yes, I am.
All right. Well, wonderful. Thank you so much.
Thank you.
Thank you. We have another guest who's going to share us a little bit, some more innovations and inventions. And it's right over here.
Hi there. My name is Mohammed Ibn Zakaria Al-Razi. I'm a chemist. I used to be an alchemist until I used the scientific method. A physician, a musician, a person of many trades. And what you see before me is something we call an alembic still. And this is actually a modern replica of what we used back in the 10th century, over 1,100 years ago. And we use it to make this. Now, in this little bottle is something we call rose water. It's very fragrant. Charlie, mind joining me?
Oh, sure.
Have a smell. Pretty good, huh? Pretty strong. People would use that after they bathe. They put it in their hair. It's a type of perfume. People still use it today. Now, the way that we make it is through a process called distillation. Basically, this pops right on. You put flowers in here and then a mesh so it doesn't fall out. That's really important because right in here we put our water and then we put it on a stove. Now, the evaporation cooks the flour, which in turn makes the oil inside of the flour evaporate, and it travels down this pipe. It starts to condense. Now, every drop that we make is money, right? How do we make sure that we don't lose the moisture to the air? Pretty simple. Check this out. Behind here we have a pipe and another one. So in series, we add really, really cold water going in and out to keep this entire thing really cold. It's basically a giant condenser. And what that does is it slows down the gase's molecules. Gases have very fast-moving molecules, and it forces it to further condense. If you take a look in here, you can see that coil. And it's very long, so it's exposed there for a very long time. That way we get every single drop. And finally, our rose water comes out of here. Pretty simple process. So with this process, we can make perfumes, we can make medicine, essential oils, rose oil, boring stuff like that, right? Check this out. Inside this little bottle is something really revolutionary. See, this is called naft. It's a type of crude oil. It's directly from the ground, very impure. But if we put it in this chamber, just like the flowers, and it went through the same distillation process, you guys know what I can make? Pure petroleum.
Wow.
So your gasolines, your fertilizers, kerosene, most of these synthetic things you see in your home, in the world, or in this room, would not exist were it not for this 10th century science. Anything from your phone to synthetic clothes to cars. Pretty crazy stuff.
That's pretty incredible.
Yeah.
So I guess my question is, when you invent something like this, how do you inspire the next generation? What advice do you give other inventors about things that they could possibly explore?
My biggest piece of advice is to start and to tell everybody about your inventions. Because somebody out there will actually want to fund you or will give you more ideas or work with you, you know? As long as the idea is spread, we can all use it, we can all innovate.
Awesome. All right, do we have any more questions? Maybe from some of the classrooms? You guys feel free to just tune in and ask those questions as they come up. It's pretty interesting, and actually I can, just by opening that a little bit, it's still in the air, really, really fragrant. Yeah, you guys smell it too, right? Maybe not.
Any questions, please? Ask away. I wasn't only a chemist. I was also a physician, a musician. My book, The Secrets of Secrets, is actually a wizardry book. I can tell you all about that.
Interesting.
See, before chemistry was a respected science, they used to call it alchemy. There was a lot of superstition back then. So it wasn't until I used the scientific method. Now, anybody who uses the scientific method is a scientist. That's how chemistry was first brought into respectable science. Oh, you have a question?
So our question from Rebecca is, why do they make those? And maybe we double up on that and say, why did you think of making this specific kind of invention?
Well, you see, back then, we wanted to create other elements from things we could find around. So, for example, lead, we wanted to turn that into gold. And we tried various methods. Distillation was just one of the many ways that we tried to convert different elements to something else, which we found out is not possible unless you're in a very expensive laboratory, and the product is much more expensive than the actual gold.
Right, right.
What is it made of? It's made out of copper. Now, the reason it's made out of copper, at least this one, is because copper has antimicrobial properties, so you can actually get the purest substances out of it. Cool. How long does it take to condense? It depends on the material that you're using. You know, if you put a lot of material, it'll take much longer, if not, vice versa. Can we make a model of it at home? Well, the one that you're looking at is actually a modern replica, so you can buy this right now. See, I'm from the 10th century, but my colleagues from the future tell me that you can actually buy this in a faraway land called Amazon.com for about $300. How long does the process take? It depends on how much you put in here. So if you put a lot, much longer.
Interesting.
We
had another question. Again, and maybe we missed it, but why are there flowers?
Why are there flowers? Because we use the petals from the flower to make this rose flower. Okay. It's directly extracted.
And those go right inside here.
Exactly.
Mesh screen underneath so they don't fall through. Great. Thank you so much.
Thank you.
Thank you. That was incredibly fascinating. Okay, so we're going to come right back over here, and we do have one more special guest that I'd like to introduce you to. And let's see. I'll get you set up. Nope, wrong way. How about that?
Great, thank you.
Tell us a little bit about what you've got there, who you are, and what kind of contributions you've made.
So my name is Maryam El Ijliya, or you might know me better as Maryam El Astrolabi. I'm from 10th century Aleppo, Syria, and I'm a famous astrolabe maker. So these devices were very sophisticated navigation and time-telling, intricate instruments. So what that means is that you have the predecessor to your cell phone. It told you the time. It was a map. Also, since these people of this time period, of my time period in my land, were very pious people, they also needed to know what times to pray and which way to face, and this also helped with that. So it was also a religious instrument as well. And how this worked is that so it was a cross between a sundial and a constellation map that were its primary purposes. So you have this outer rim, and that told you the time. So you would align this with the position of the sun, and that's how you told the time. And then this inner circle is a constellation map. Now, for those of you at home who don't know what a constellation is, it's the picture in the sky stars make when you connect them together. And why that's a reliable way for you to travel is that stars are only in the same place once every year. So it's a great way to tell whether you're north, south, east, or west and which direction you want to travel. And the way this works is that this circle here is that it's a month and a day. So I know how to turn this based on the month and the day. So I don't have to stop my crazy adventures once the sun sets. I can keep traveling even at night. Now the back is where it gets even more interesting. So if you see right here, you have what are almost like angle measurements, if it'll be in focus, and I can tell the lunar cycle from it. And when I know that, I know the times to pray because the Muslim calendar is based on the lunar cycle. So this intricate device was both for religious and scientific purposes. So much like how you have different versions of your cell phones, there were different versions of the astrolabe. So as we kept innovating math and science and astronomy in general, we had to keep making newer versions of the astrolabe. So I'm not actually the inventor of the astrolabe. I was just very talented at making newer versions. I was so talented, in fact, that the Khalif, or the king as you would call him, in Baghdad, Iraq, he asked me to come make astrolabes for him, and I did so for over 20 years. So I'm a very notable person, not only in the scientific community, but also in government and in court as well. So does anyone have any questions at home? None about women in science or women in politics, technically. I was in politics as well. Who invented it? Well, it was a very old invention. My father actually taught me how to make them, so there wasn't an exclusively one inventor, so to speak. It is kind of like a compass, Miss Yasmin, in the sense that you can use the stars to know where north, south, east, and west are. However, it doesn't operate on a magnetic field. It works on the position of stars. What is it made of? It could, Miss Wendy, well, it could be made of a variety of substances. It could be made out of copper or intricate metals, depending on your budget and who's commissioning the astrolabe. Can I make my own? Yes, you can. In fact, we will be attaching a description of how to make your own paper astrolabe at home. So you guys can also be tracking star movements and doing all sorts of fun scientific things. So, Miss Yasmin again, what are those designs on the inside? These swirls are supposed to represent certain constellations. And if you step closer, you would also see the names of very identifiable, noticeable, easy to see constellations. Although now it's harder to see constellations than it was in my time.
Well, thank you again so much. I do have one more question for you. Maybe you can help us sort of understand some of the other topics that are covered in this incredibly huge exhibit with all these different 60 interactives. What other things can we learn about?
We could learn about health and medicine and the many contributions that happened in this time. We have El-Shifa, who's the famous herbalist. She was even noted in the Quran, as well as the development of what we would think of as now as hospitals in this time period, and all the way in Damascus and Baghdad, as well as the famous surgeon Al-Zahrawi. We also have some famous traders and travelers. We have all sorts of things. It wasn't really exclusive just to science or chemistry or engineering.
Yeah. It's pretty incredible. Any other general questions about this exhibit while we have someone here, an expert that can sort of tell us all about the rest of the experience here? Maybe we have one on Facebook. Oh, okay. So if you could just tell us again, how old is the astrolabe? When was it sort of invented or
This would be relatively in the late 800s, 900 AD.
Oh, wow.
And then it was continually used into the Renaissance when they were traveling to America as well as South America.
Incredible.
It was very useful because it's so portable as opposed to the sextants and other navigation devices. It's a disc, it fits in my hand, it's actually not that heavy. So it was very revolutionary in that matter.
Amazing. All right. Well, again, thank you so much for joining us today. It was much appreciated, just sharing about this incredible experience, your contributions to to science, and just the innovations were really remarkable.
Thank you. And you guys should come to the exhibit and see more notable women in science.
Absolutely. So I did just want to say a couple more things as we sort of sign off here, and thank everybody for participating in this webinar with us. I do want to let you know once again that 1001 Inventions is free to the general public and school groups that come to the Science Center if you pay your general admission. So if you come down to the Science Center during the holiday season and you're looking to come see this exhibit, there's no extra charge. It's the general admission, and you can come up here and get a tour of this incredible exhibit, meet some of those scientists that we met today, and more. We've got some hands-on activities that are taking place in the back corner behind me, all ways to explore some of the different innovations and achievements of this incredible era. This entire exhibit was made possible with the help of Friends of 1001 Inventions Michigan. This is an active local community group whose efforts really helped bring this exhibition to Michigan and made it to the Michigan Science Center and all of the guests for free. So really an incredible experience, and we want to thank them and point out their contributions to this incredible exhibition. Again, my name is Charles Gibson, and I'm the Director of Innovation and Outreach here at the Michigan Science Center. I want to remind you a couple other things. This webinar that we're having right here is an example of our ECHO distance learning programs. You can check out some of those distance learning programs that we offer on our website. If you go to the Educator tab and click on to Traveling Science or Distance Learning, you can learn about some more interactive video conferencing experiences that we have for you. Things like frostology, where we're learning about winter weather and doing some really cool experiments. We also have Burn Boss training, where we're learning about engineers and how they control fires. Journey Without a Map, where we're learning about the stars. Just some really great programs, all interactive. And instead of this type of connection where I can't actually see you and I can't hear you, I'll be able to see you when we have those other types of interactions. And we can ask each other questions. I can make sure that you guys are doing the experiments properly, and all sorts of really great experiences. The Michigan Science Center is open during the holiday season. I want to let you know that. We are closed on Christmas Eve the 24th and Christmas Day the 25th. But we are open again for free for our 5th birthday. That's December 26th. We're going to be open from 10 to 8 that day. And throughout the holiday season on weekdays, we're going to be open from 10 to 8. So please come on down, check us out. With general admission, you get admission to this exhibition, and it is incredible. You don't want to miss it before it leaves here on January 7th. That is the final day. That's the final day to see that exhibition. We will be closed, just as a note, we will be closed January 8th through 14th. That is where we're going to be doing some maintenance projects inside the building and getting it all spruced up for you in the new year. But please, come down, check us out for the 5th birthday. It's free general admission that day, so you do get to come and check out our incredible exhibit here in those final days. I want to thank you guys once again for tuning in today with us and checking out, learning a little bit about 1001 Inventions. I hope that you have a wonderful and safe holiday season. Again, my name is Charlie with the Michigan Science Center. Thank you very much, and have a wonderful, wonderful day.